Welcome to this second video on how to manufacture the Steenbeek foot abduction brace, the SFAB, also known as the Steenbeek clubfoot brace. My name is Michiel Steenbeek. I work with CBM, Christian Blind Mission, and I'm based in Kampala in Uganda. Today we are still here at Katalemwa Cheshire Home and Rehabilitation Center in their orthopedic workshop in their metal section. I'm together with Arthur Lubwama, who is the brace maker and the metal worker in Katalemwa, and together we will explain to you on how to make the abduction bar for the Steenbeek brace. In the previous video you have seen and we have collected all the different parts for the shoes for the Steenbeek brace. Now we need to make the metal abduction bar. So we need to construct this one. Looks pretty simple, but let's go through it. So we need a bar and we need 2 plates. That is the beginning. So in the manual, which is on globalhelp.org, on page 7, there is a table and it specifies for which shoe size you need which length of rod. So we're making size 11 shoes, which needs a rod of 12 inches or 30.5 centimeters. So to collect that rod, you go to your supplies from the factory of 6 millimeter mild steel. Maybe 7 millimeter is also acceptable. So from that bar, you cut 12 inches as per the table in the manual. So we have done that. Simple. This is the rod. But we also need 2 plates. Plates can be cut from a bigger plate of 1.2 millimeter, sometimes 1.5 millimeter. So that means you need to get a plate from the factory and make lines on it of 2 centimeters wide and cut those ones. We've also done that now. Arthur has done that. A long strip, 2 centimeters wide, and you then cut it at 6 centimeters. Okay? So you can, for mass production, you cut many plates and rods, obviously. So we now have the 2 plates and the rod. Now these 2 need to be welded onto the rod at 70 degrees external rotation, which in the clubfoot world we name it as abduction. So let me first explain what is 70 degrees external rotation. You can see these are feet. And I have a drawing here that I made with the goniometer. If the feet are pointing straight forward in the same direction as your nose, that is the 0 position. That is 0. External rotation is towards that side, 45 degrees, and then you come to 70 degrees. And here we externally rotate or abduct also. This is 70 degrees for both feet in relation to your frontal plane. So on the goniometer it looks like this. Meaning if I put this here, or meaning if I go to the neutral position of this and I externally rotate, then this is 70 degrees externally rotated. If I compare that with the drawing, then it is correct. On the other side, obviously, it is also correct. Now we need to make a jig that will help you to weld the plates to the rod. To do that, take a piece of flat bar of a bit more than 32 centimeters, and you bend it in a way that it matches the drawing of 70 degrees externally rotation. So this one is here and it is correct. This one was also bent by Arthur in the right way of 70 degrees. So this is going to be your guide for the welding. In addition to that, you have to put this, so you have to weld this here on a piece of hollow section, mild steel hollow section, and this piece is 2 inches by 1 inch. Weld it in the middle. The length between these two marks where the bend is taking place is 8 inches or 20 centimeters. Work for the shortest rod that you can make, which is for size 3 and size 4 shoe. So that needs to be welded in the middle here, and we have also done that, and then you end up with a jig like this. If you then start making the smallest shoes, let's say 4 or 3, and you're going to place the 2 plates lengthwise at the level of the bend, which is 70 degrees, and you then put the rod there, then the tips of the rod will end up in the middle of the 2 plates. You can then spot weld, take it away, and then you have your bar. But this jig that will work for the smallest shoe and the abduction bar, it will also work for longer bars, for bigger sizes of shoes. Now, how is that going to work? Let's say you put your plate here, lengthwise, according to the bend. Then you put your bar there, the tip in the middle of the plate. You spot weld, then you shift it to the left, put the other plate, you shift it that far that it also ends up in the middle of the plate, and then you spot weld again. Then you're going to end up with this, spot weld it, take it to the side and complete the welding. So one jig works for the smaller sizes of shoes, meaning the shorter bars, and it also works for the bigger sizes of shoes. You will understand that small shoes have a short bar, bigger shoes have a longer bar. So it is good to have one jig that works for all the sizes, instead of that you need to have a jig for all the different sizes. So we now have a rod at 12 inches for size 11 shoes, and we have 2 plates, and those ones need to be welded together, and Arthur is going to do that. He'll put on his goggles and put the plates along the bend of the jig, shift the plate so that the tip of the rod is coming in the middle of the plate. Then you shift it to the left, position the other plate, put the tip of the rod in the middle of the plate, and spot weld it. And you take it away and you do the final welding, not on the jig, but on the table. And it is finished. So now we have a rod and two plates welded on each other at 70 degrees abduction. But we need another bend in this bar. As I mentioned, the shoes are also in dorsiflexion on the bar. Okay, so now we need to get that bend of 10 to 15 degrees dorsiflexion in another jig. And now explain again on what is 10 to 15 degrees dorsiflexion. The foot needs to do this movement. That is dorsiflexion. So again, I have my goniometer, and I have a drawing here on this plywood, basically showing that if this is the neutral with the feet flat on the ground, and I go 10 to 15 degrees up here, and I put it at 15 degrees, then that is what I want. In the jig, you want 15 degrees. So from the foot side, it looks like that. If I put it along the jig or along the drawing, then it will be like that. Now, how are we going to do that? I have two pieces and two, let's say, examples of jigs. This one is an angle iron, and it has been cut a little bit on top and more on the bottom, so that it can bend, and the bend between those two lines is 15 degrees. Okay? So the angle iron is now at 15 degrees. There is a loop here under which you can slide the bar or the abduction bar as far as you have it now, and then you can bend it down, which I'll show you later. And this is a similar one. This is a flat metal with a reinforcement below. You've constructed it in a way that the flat metal will bend down at an angle of 15 degrees. There's a slot here, and there's a round bar here around which the bar can bend. The distance of the bend in the bar is just outside the shoe, and it is about 4 to 5 centimeters from the tip of the bar. So on the jig, the distance from that loop to hold the plate in place to this bar around which the rod will bend is about 4 centimeters. Okay, 5 centimeters doesn't matter so much. This one is also 4 to 5 centimeters. So we can then show you how to bend it. You place the jig in the vise. You take the bar and you slide it under the loop, and then you will bend it down, and what you then get is 15 degrees of dorsiflexion. You can then compare with your jig, and then you will see that it is just under the 15, meaning it's between 10 and 15 degrees. If it is not enough, then you can, apart from bending it down, you can also hammer it further so that it doesn't spring back so much. Some steel is very hard and it jumps back more, and some are not so hard and it stays in place. So now we have all the shoe parts, and we have the metal parts. Now we can assemble the brace. So we'll do the assembling in the next video, which is the third video. Please click here for the third video, and then I'll see you later.